Hi, okay, so we're ready for lesson 2, the checkpoints. And so again, on the left-hand side of the screen, you can see that I have the Unit 1 theorem review up, and this is located in the course announcements under the unit reviews. And so this is the Unit 1, and I scroll down to lesson 2. So we're going to start with question 10. Use the following figure to answer the question. Okay, so I see a circle, I see a point N, a point M, and a point L. What is the correct name of this circle? And so I'm going to see in the theorem review if there's anything regarding a circle. And right now I see a circle, and it says when you name a circle, you use the point with a circle around it, symbol to mean circle, and you use the name of the circle and you use the name of the center to name the circle. The circle shown is called circle C. So that's because the center is at C. So on this circle, the center is at L, so the correct name of the circle is L. So now we're going to scroll to question 8. And I'm going to be doing every other one just so you have some time to practice using the review on your own and or your own notes. So use the following figure to answer the question. So I'm looking at this figure and I see 3 rays. They start at the vertex B, and then we have ray from here. Let me highlight. We have ray BD. That didn't highlight. We have ray BD, we have ray BC, and we have ray BA. And the reason why I called it BD is because of the point located right here, BC, the point located on the ray, and BA, the point located on this ray. The other thing that I want you guys to notice, or if you haven't already, is that they have marked angles. So angle 1 starts where the purple arc ends. So there's one side of angle 1 and the other side is right here. So that's angle 1, and then angle 2 is BD right here. So what is another name for angle 2? Okay, so I'm going to look for angles on this, say I don't remember anything, and so we have this angle addition postulate, and I see a similar ray, and then I look at this, it says if D is located in the interior of angle ABC. Well, this is giving me an idea. It's not necessarily directly related, but it's giving me an idea because it says angle ABC. So I can see that there's a point A, I see the other point B, and I see the point D. If I follow those in that order, that is an angle right there. So that's another way you can name an angle is by the 3 points, and you always start with a point that is on a ray. So for angle 2, its sides are BC, so I could start with the point C, so angle C, and then I go to the vertex B, and then I go to the other ray D. So this is angle CBD, or we could go the other direction. We could start on the ray BD, and we could start at point D, and we travel to point B. So angle D to point B to point C. And that's why I like the names of the angles that include the points, because it's directions. I start at the beginning and I'm going to follow straight in order. So from point D to point B to point C. And that is my angle. So then I'm going to be looking for either one of these names. So I noticed that the first one is angle CBD. That's the first one we had up. The next one, angle A, no. Angle DB, almost, and then it goes to A. So no. Angle DC, no. Angle BD, no. So there's only one of our two options. So now we're going to move up to question 6. Use the following figure to answer the question. So in this we have 3 lines. We have line A in orange, line B in blue, and line C in purple, with this square that's touching line C and touching line B, and that square means that they are perpendicular. That is the mathematical way to represent perpendicular lines. Now it says, which answer choice correctly describes the relationship between two of the lines in the figures? Okay, so now we need to know some math terminology because I see B with this upside down T and C. The upside down T means perpendicular, so it's pronounced perpendicular. So is B perpendicular to C? Yes, because of this drawn in square right there. So B is perpendicular to C. Is A perpendicular to B? So I'm going to look at the intersections where A and B meet, here and here. Oops, just there, sorry. A and B meet right there, and there is not a green square or a 90 degree written in. So no, A is not perpendicular to B. Okay, B and then these 2 bars that look like railroad tracks to C. Those railroad tracks means parallel. So if you don't have that in your notes, please include these symbols. They're very important to your success, is knowing what the symbols mean in math. So the upside down T means perpendicular and the railroad tracks means parallel. So is B parallel to C? No, you cannot be perpendicular and intersect and be parallel at the same time. So is A parallel to B? No, because they intersect. Is A parallel to C? No, because they intersect. So question 6, the only answer is B is perpendicular to C. Then question 4, a proof. There's going to be a large portion of questions on proofs. So we need to be able to follow along and learn how to work with these. So I love proofs because I have all of the rules, which are listed right here in the theorem review, and those are the only rules that you can use in the proof to prove anything. So it's like any game that you play. Here are the rules, and then you can set out on that game. So I like it because I have a list of the rules. So given angle A and angle B are supplementary angles, and angle B and angle C are supplementary angles. So we need to prove that angle A is congruent to angle C. This symbol means congruent, which means has the same size and the same shape, or same measure, I should say. Everything is the same. So the congruent symbol is the equal sign in geometry. So the statements, so angle A and angle B are supplementary angles, angle B and angle C are supplementary angles. The reason is those are given. Yes, they are given right up here. And then so we have to start with our given things, and those will usually be the very first statements that we have, and sometimes they'll be used again throughout a proof, and we will always end with what we want to prove, if you notice that right now. So we will always start with those two statements. We'll start with those statements and then we'll end with what we want to prove. That's how we know we proved it. So now statement 2, the measure of angle A plus the measure of angle B equals blank, and the measure of angle B plus the measure of angle C equals blank. And then the reason is the definition of supplementary angles. Okay, say I have no idea what supplementary angles are. There was too many things to remember. So I'm going to come back and I'm going to look for supplementary angles in my lesson 2 theorem review. So this one is segment addition. This is kind of what we're talking about, but we're talking about angles, so it's not segments. And we need to find more angles. So here's the angle addition postulate. And below that it says supplementary angles are two angles whose measure is 100 and whose measure add up to 180 degrees. So that is what goes in those blanks. What is the value for both blanks in statement 2? Because the reason was definition of supplementary angles. The definition of supplementary angles is that two angles whose measure adds up to 180 degrees. So that's how I would navigate that proof. And then we're going to jump to question 2. Use the proof to answer the question. Given angle A and angle B are supplementary angles, angle B and angle C are supplementary angles, prove that angle A is congruent to angle C. So again, notice that the given right here starts off our proof. Angle A and angle B are supplementary angles. Angle B and angle C are supplementary angles. That's the only thing that we know about these two angles, these three angles. So it's given. And then we read measure of angle A plus measure of angle B equals 180 degrees. Measure of angle B plus measure of angle C equals 180 degrees. And then we come over to the reason and it says definition of blank. Well, in order to go from I'm going to think back to what I know about supplementary angles. Supplementary angles add up to 180 degrees. So that is the definition of supplementary angles. So we're going to type that in, and please make sure your spelling is correct. So it is spelled up there. supplementarangles. So that is our blank that is our reason for statement 2. And that's what we're going to have for the checkpoint 2. And now your quote for the video assignment is by H.M. Tomlinson, and it says, "We see things not as they are, but as we are."